Logarithmic functions, you cannot get away from exponential functions. Once exponential function is introduced, logarithmic function is followed. They are brother, sister, and it's like siblings. Can't get away from it. I mean, sometimes we do, but these two functions cannot. So let me go over exponential function first. Then I want to move to the logarithmic function and then combine together. Okay, so let's start with the exponential function. Make it easy. So I want to start exponential function y equal to 2 to the x. Make it easy. Let's draw this 2 to the x. Okay. When x equal to 0, 2 to the 0 is 1. When x equal to 1, 2 to the power 1 is a 2. When x equal to negative 1, 2 to the negative 1 is 1/2. When x equal to 2, 2 squared, which is a 4. When x equal to negative 2, it's 1/4, like that. So that's 2 to the x. So I want to put this into a curve here. This is the exponential function, 2 to the x. We all okay with that. All right, so I want to make sure we have this number 1, and here's a 0, 2 to the x. Okay, and then the next thing I want to find, it is an inverse function. Suppose we have a given function f of x, and I want to find the inverse function. I rewrite it as f inverse of x. This is notation. Okay, notation is fine. The question is, what is the inverse function look like? Let me give you a general idea. No exception, it's always true. Suppose we have xy coordinate. I have some kind of function. This is f of x. I want to find the inverse function. What you have to do, you always make a line y equal to x. Always make a line y equal to x. Reflect the image by y equal to x. That's inverse function. Or you have this function here, reflect by y equal to x, that's inverse. So this is inverse of that, this is inverse of this. Do you understand this? Vice versa. So while we are doing this, I want to find the inverse of that. So I make it y equal to x, and then this function is convert that, reflect it. Let's do it. So we have y equal to x. Let's reflect. And this is our magic number 1. Okay, inverse function. Inverse function. That's magic number 1. Now, when you look at this graph, what is the most significant of this function? It's because you are reflected image by y equal to x. X equal to y, y equal to x. So the x value become y value become x value. It's kind of a interchange, vice versa. Do we understand this? Okay, so let's do it. So the question is, what is this inverse function said? The inverse function of exponential function is called logarithmic function. We have 2 to the x, so log base 2x. Write it out this way. Do you understand this? If original function is a 3 to the x, what's the inverse of this? It's a log base 3x. If it is a 5 to the x, it's the same shape. It's only steeper or slower. It's log base 5x. Do you understand the idea of doing this? Okay, many people think logarithmic function is hard. It's because of the wording, but this is just the inverse of exponential function. So in general, a to the x, and you want to find the logarithmic function as its inverse function, log base ax. What's important? This base is the same as that base. Do you understand that? Okay, let's go over once more. Okay, suppose I have 2 to the x inverse, so this is f of x, and that is f inverse of x. Okay, f inverse of x. log base 2x. Okay, 10 to the x inverse log base 10x. But we don't write it this way. Log base 10 is skipped. We just write it log x. So if you don't see any base here, means 10 is skipped. Do you understand that? So log base 10x, 10 is skipped. So write it out as log x. So you have a calculator. The calculator has log x. You don't have log base 2x. Or you don't have a log base 3x. Log x. 10 is skipped. E to the x, log base ex. We don't write it this way. We write it ln of x. Notation. Okay, so this is a natural exponential function. This is a natural logarithmic function. Ln of x. So ln of x is log base ex. Do you understand this? Ln of x is log base ex. So I want to erase this. So instead of say these points, okay, I want to just write it out as a to the x here in general. And this is a log base ax. Write it out this way, notation. Okay, one picture shows 1,000 words. So let's analyze blue curves. Okay, so let's see how much we understand from the graph. Okay, let's see. Number one, log base a1 equal to 0. This is corresponding a to the 0 is equal to 1. Okay, if you want to convert this to natural exponential function, natural logarithmic function, here is 1, e to the x, and here's ln of x. This is the guy, same thing. Okay, this is guy. This one, e to the 0 is 1. This one, ln of 1 equal to 0. Okay, so we are having one step furthermore from the original exponential function, just one step furthermore, y equal to x. So far so good. Next one, this behavior, a to the power negative infinitive is 0. Same thing, e to the power negative infinitive is 0. So instead of a, we have e. That's what it is, okay? So there are two parts here. Corresponding part is this. Log base a of 0 is negative infinitive. Remember, x and y are interchanged. Okay, x and y are interchanged. Right here, ln of 0 is negative infinitive. One corner, okay. A to the positive infinitive is positive infinitive. Same thing here. Log base a to the positive infinitive is positive infinitive. So here is the same thing. Domain of a to the x is all real numbers. Range of a log base ax is all real numbers. See, domain and range changed. The range of a to the x is 0 to infinity. Domain of log base ax, that is 0 to infinity. It's because it's reflected by y equal to x. So all this x value condition goes y value and vice versa. Okay, so domain become range, range become domain. One more. Oh, can I? Okay, f of x equal to a to the x. Inverse function, that is log base ax. They're inverse each other. The function and the inverse of a given function is the identity, original, or inverse of original function is the identity x. So I want to combine these together to find that. First, f inverse function, which is a to the log base ax, which is equal to x. Okay. The second part, f inverse of a to the x, which is log base a to the x equal to x. Identity. Now we want to write this in terms of e log base ex. I just replace e. That's exactly same as e to the ln of x, which is x. Log base e to the x, that is ln of e to the x, which is x. Okay. On top of this, a to the 0 is 1. Log base a 1 equal to 0. Same thing, e to the 0 is 1. Ln of 1 is equal to 0. Okay. This is the key point of the section. And all this, the blocks, you must be memorized. But you are not just sit down and memorize. Of course, we have a graph right above here. Let me just make it a little bit smaller so you can all see it. Okay, so this together, make sure you understand and memorized. Okay, so once you are done copy down, let's practice. Okay, so I go slow. Let's see how much we understand those properties. Okay, 1.8, write an equation in its equivalent exponential form. Let's first look at the first equation. It already have a solution, but I want to show you why I get this guy. Okay, so here you go. 3 is log base 7x. The important part is this base 7. Important part is this base 7. Okay, so I want to raise both by 7. That's what it is. I want to raise both sides, raise by 7. 7 cubed, which is 7 log base 7. Remember, a to the log base ax equal to x. So this is just x. So 7 cubed is equal to x. That's how I get this. All right, let's look at the next example. Let's see. How do we get this guy then? 2 is log base b 25. Here's a base b. Here's base b. We raise by b for both sides. B squared is 25.
B is 5.
B equal to 5. So this implies B equal to 5. All right, let's look at another one. Number 3, y equal to log base 4, 26. Important part is this base 4. What do we do with this? Raise by 4 on both sides. 4 to the y is equal to 26. 4 to the power is 26. Some number out there. Do we understand these three concepts? What's important? This is important.
4.7004.
4.704, something like that. Okay, this is not important. This is important. Okay, that's fine. All right, let's move to example 1.9. Let's see how we solve this problem here. Again, it's given this. Okay, so but let's try this together. 2 to the 5th is equal to x. So this base is important. So 2 to the 5th. I want to raise both sides by log base 2. Log base 2. So the formula says log base a to the x equal to x. That's what it meant. So the left side is 5, right side is log base 2x. That's, we get this. So this is important. Okay. Try next one. Try again. Okay. B cubed is 27. Here is a base b. Log base b log base b. So left side is a 3, right side is log base b, 27. Okay, let's look at the last one. Here, e to the y equal to 3. Okay, e to the y equal to 3. E to the y equal to 3. E is the base. Log base e, log base e. Okay, y equal to log base e3. But log base e, this is ln of 3. Any question? Okay, we have one more. Here's number 10. Okay, log base 10 of 100. Okay, so log base a to the x equal to x.
2.
Log base 10 of 100, which is log base 10 of 10 squared, which is a 2. Do you understand this? This is one way to do it. Okay, let me show you another way. There are a couple of ways to do it. Okay, another way that is, let's say x equal to log base 10 to the 100. Here's a base 10. I raise both sides by 10. Here's a 10. 10 to the what power is 100. The power is 2. So same answer, one way or another. Okay, the next one. And now you decide which one could be easier. Doesn't really matter, whichever you like. Log base 3. You kind of write it out somewhere here. Here's a 3, here's a 3. A equal to a, 3 to the power 1, so it's 1. Or x equal to log base 3, and this is base 3, so you raise both sides by 3. 3 to the x is equal to 3. What power is this? 1. 3 to the what power gives 3, which is 1. That's exactly what it is. So you can look at this way, or you can directly look at the formula that way. Whichever you like, that's you can do it. Okay, so for me, this is easier. Get used to it. Okay, maybe for you, this is easier. Same thing. Okay, let's try another one. The last one. Log base 36. So x equal to log base 36 to the 6. Base 36. 36 to the power equal to 6. What power is that?
1/2.
1/2, right? Square root of 36. Yeah, this is square root of 36 equal to 1/2. 36 to what power gives a 6? That's exactly what it means. Okay. Are we okay with this? Is it hard? Let's try on more examples here. Go ahead.
Let's say like on a quiz or an exam, if you were to give us a problem like that, would it be solvable numbers, or we would have to use our calculator?
More likely solvable number. I try not to use a calculator. The only time you use a calculator is those examples that we had from previous section, something like e to the negative 0.97. There is no way you can do by hand. Those are needed calculator, but all the others, I make it straight and simple, so you are able to write it out.
Okay, sounds good.
Okay. All right, let's move to next page. Properties of log. Okay, let's review once more. We already had this. Log base a of 1 equal to 0. Log base a of a equal to 1. And these are two exponential and logarithmic function together. It's because they are inverse each other. So I want to go back to the page right here. These guys are again written in the box. Okay, so let's go back to page 11. Okay, let's have this. Example 11, evaluate. So proposition, the properties of log is given right above. Okay, so for this time we have a properties on our page, but more likely property will be disappeared. Make sure you remember these properties. Let's see, evaluate it. Log base 6 to the 6, that's power 1, so it's 1. This guy here, okay? Log base a to the x equal to x. Log base 5, 1. No matter what base, log of 1 equal to 0. Log base 7, 7 to the 8th. 7, 7 to the 8th, 8. 3 log base 3, 13, which is 17 is 17. Question. Okay, so when you turn the bottom, not really turn the page 11, example 12 graph 3 to the x and log base 3x in the same rectangular coordinate system. This is something we just have done. 2 to the x we have done. 3 to the x, the important thing, number 1. And then we put y equal to x, reflect the image, important point, number 1. This is 3 to the x. This is log base 3 to the x. That's what it is. Okay. Instead of 3 to the x, log base 3 to the x, if I ask you to find the e to the x and the ln of x in the same graph, no problem. You write it 1 e to the x, y equal to x, reflect the image, 1 ln of x. That's all you have to do. Do you understand the the idea? Do you understand the pattern? What if I ask you, instead of ln of x, instead of 3 to the x, I'm going to erase this. If I ask you to find, okay, here's a 10 to the x, here is a log x. Can you draw in the same graph? Sure. Here is a 1. Here's a 1. Of course, there's y equal to x. So do you understand the pattern of doing this? Okay, so these are important, magic numbers. Okay, let's look at this guy. How do you solve this? We had a log x, okay, log base 4x. We didn't have log base x minus 5, so it does have a little bit of shift here. Okay. Important part is this guy, right here. Okay, what makes your log function equal to 0 here? So right here. Okay. So when you look at this guy, inside of this guy, right here, this means a log base 4x for 1 equal to 0. Do you understand this? I want to find this guy, so I can make it to 0. So for here, you want to make it this number 1. So you have 1, x minus 5 has to be equal to 1, x equal to 6. So this is a 6. So this guy that we want to find, log base 4, 1 equal to 0. Okay, and you graph it? Of course. This time you cannot let pass, it's because this guy is the only difference of 1. There's x equal to 5. Shift 5 units to right. Okay, so how do I know this guy? It's because of this. So make sure you understand that little transformation from one to another. Okay, next page. We have discussed common notation. There is a 10. 10 is skipped. There's an E. We rewrite it as ln of x. We have seen this before. Okay, so make sure you get that. All right, find the domain of 2 plus log base 5x. Okay, log base 5x, here is a magic number 1. To add to it, everybody move 2 units. So this is 2 plus log 5x. This is log x, x minus 3. I want to make this guy equal to 1. It's because, okay, remember, log base 10, 1 equal to 0. So I want to make this guy equal to 0. X minus 3 equal to 1, x equal to 4. So you see this number 4 here. Okay, shift to the right. So transformation, let's try some transformations. Let's first look at this guy. Log base 2x, let's start with that. Always have number 1. Always have number 1 right here. Okay. This is log base 2x. Okay. What if it's a negative here? All of these guys are negative of that. Okay, negative of this. So what we do, you flip this by that. Positive become negative, negative become positive. There's still one. Now we have a negative inside here, negative inside here. Okay, So from the original, you always go back to the original. This is the original, the negative. So here's a positive 1. Now you have a negative 1. It's become this guy here. Okay. So another way to say this guy is flipped. Okay, so what's important? Always important, start with the original. Okay, always important to start with the original. All right, so I want to go back to the page 11, just for a small thing that I have to point it out. I forgot to point it out. The proposition 1 from this guy, big, so we all can see it. Log base A here, this A, I want to replace all this A by E. Okay, let's change that. Change this. So if I change this, it is a log base E1, which is ln of 1 equal to 0. Log base E of E, this is the A equal to A, E equal to E, which is ln of E, which is equal to 1. I want to replace everybody E, okay? Log base E, E to the X, which is ln of E to the X, which is X. One more, E to the log EX, which is E to the ln of X, that is X. So on page 11, this is all about the general exponential function to the logarithmic function. Now, in a few pages after, we have a natural logarithmic function. So I want to rewrite it thus. Go back to this guy right here. Ln of 1 is 0. Ln of E equal to 1. Ln of E to the X equal to X. E to the ln of X equal to X. The only difference is we just replace by E instead of working with the A. All right, let's have an example here. Example 16, it has 4 parts. Let's try it. One more, this is important. Ln of 1 equal to 0. Ln of E equal to 1. Ln of E to the X equal to X. E to the ln of X equal to X. Okay, those 4 parts. Okay, first question. Ln of E to the 7. Ln of E to the 7 is a 7. Okay. Ln of 1 over E2 is in the denominator. Ln of E to the negative 2. Or this is ln of E negative 2, which is negative 2. Okay. This is a little tricky here. We need to find X. Let's do this one. E to the X plus 1 is 0.5. Rewrite. E to the X plus 1 is 0.5. I want to get rid of this E. Oh, go ahead.
Would it be 0.5 minus 1? So negative 0.5 plus 1.
Negative 0.5 plus 1.
Because e to the power of x is equal to x.
ln of e to the power. So let's raise this to ln. Okay, I understand what you're saying. Okay, let's raise this to ln. So ln of e to the x plus 1 is x plus 1, which is ln of 0.5. That's what we have, right? Okay. So x equal to ln of 0.5 minus 1. Okay, I want to write this into the red marker. Nothing wrong with this, but I want to give you one alert here. This is really important. I asked students to simplify it. Students usually write it x equal to ln of 0.5 minus 1 and write it out as ln of negative 0.5. Write it this way. The answer is wrong, because often we combine these together. To avoid this confusion here, I rather write it x equal to negative 1 plus ln of 0.5. Write it this way. Okay, so I want to give you one. Anything, okay, beyond, after logarithmic function, exponential function, trig functions, okay, bring it up front. Bring it up front. So let me give you an example. So we are avoiding our own traps here. So for example, if I say x equal to ln of 2 minus 3, often students says it is like a plus 3, doesn't really matter, 5, which is not correct. Rather write it 3 plus ln of 2. Do you understand this? So you can avoid your own traps. One more example. Later on, we are going to study trig functions. So sine of 30 degrees plus 15 degrees. Students often say it is a sine of 45 degrees, which is incorrect. 15 plus sine of 30. Do you understand this? So you don't want to write it anything beyond the trig function, exponential function, logarithmic function. All clear? This is one habit. Actually, my calculus teacher taught me. Before, when I had a calculus, I didn't know this. I always trap myself. And my calculus teacher taught me, and it was very helpful. And from then, I try not to make myself on trapping here. So do we understand this? So anything beyond logarithmic function, exponential function, trig functions, bring it up front. Clear? Okay, so instead, if I set this way, I want to write it out. Something up front, I write it. X equal to negative 1 plus ln of 0.5. Okay, let's try this guy. Okay. E to the 0.5y equal to 1. I raise both sides by ln. So 0.5y equal to ln of 1. ln of 1 is 0. 0.5y equal to 0, y equal to 0. Do we understand this concept? Maybe, maybe not. We get confused. Okay, I want you to turn the next page. Problem 13. Okay, let's do it now. Even though this is a part of our homework, but I'm not so sure how many of you are completely understand this particular topic. So let's try 13 together. Okay, few minutes. Number 1. Okay, part A. Log base 8, 1.
0.
0. No matter what base it is, 1 is always 0. 2 to the log base 2, 13.
I got 13 also.
13, very good, 13. Who answered, Alina or somebody else? Alina, okay. E to the power 2 ln of 7.
7.
So this is a 7. Did somebody say 7? Okay. Yep.
Would it
So
be
this is a
7
little
to
bit tricky here.
Would it be 7 to the power
Somebody
2?
say 7. How'd you get 7 to the power 2?
Because you have to move the 2 to the exponent.
2 to the exponent. Okay, so we have ln e to the ln combined together 7, that is a 7. We have e to the ln of a 7 squared, that becomes 7 squared. That's okay, but we do not have e to the number then ln of 7 because this number bothers us. You know what I mean? It has to be e to the ln, not e to the number ln. So now here's one more trick property. If the number comes in front of a logarithmic function, it goes to the exponent. Okay. So another way to say, let me write it nicely. Suppose we have, okay, e to the number ln of a b, you bring this number to the power. So this is a b squared. Do you understand this? It's the number, we go to the exponent, not the multiplication. So we rewrite it, e to the ln of a 7 squared, that's 7 squared, which is 49. Okay, so this is something new, that's a new property, and we're going to discuss in next section, but this is somehow, it's hard for us to evaluate it. Okay, one more, D, this is hardest part. Let's skip D and let's do E first. Can we do E?
Does the log of a log cancel each other out?
No, you cannot cancel log and log. You have E and log, yes. A and log, yes. But log and log cannot be cancel each other. It's a tricky too. Let's see. It's the part. This is the log of log, like that.
Quick
Could it be?
question.
Mm-hmm.
So you said that if in a log, if the 10 is missing, or if there's no base,
Mm-hmm.
it'd be a log 10. So would that be
Yes.
log, like log 10 of log 10 to 10, and then an exponent of 100, or something like that
Yes.
at least?
That's what it is, exactly. So let me rewrite it, exactly what Alina says. Okay, let me rewrite it. Log base 10, log base 10, 10 to the 100. That's Alina says. And that's exactly what it means. If there is no base, 10 is missing. All right, let's look at this guy. What is this?
100?
100? Okay, 100. This is 100. That is log base 10, 100. What is this guy?
Squared 2?
Square root of 2?
No. Squared. And then I meant to say 2. So 10 to the power 2 equals 100.
Okay, so we rewrite it. It is a log base 10, 10 squared. So it's a 2. That's what you said?
Mm-hmm.
Yeah, that's what it is. Are you doing good?
A little tricky.
A little tricky. Yeah, even that's a tricky question. In fact, part D, this is even trickier. Okay, so I want to struggle this for the weekend, and we're going to go over this Monday.